Hello, so I'm still working with these parametric equations, and this time I've been asked to find the Cartesian equation of the curve. So if you remember, the whole point of parametric equations is that we take some really kind of usually horrible function, kind of all mixed in together, and we basically just introduce a new parameter, we call it, but it's basically like a new variable, and we just introduce our original variables as functions of this new variable. So this is literally what's going on up here, okay? And the reason why we do that is because it makes it easier to differentiate and makes it easier to integrate, for example, and we'll probably be able to see what's going on a little bit better. So basically what this question is asking is find the Cartesian equation of the curve. Well, Cartesian equation comes from the whole idea of Cartesian coordinates, named after a mathematician called René Descartes, who discovered it. And it's basically just involving the x's and the y's and z's if they're there. But in this case, we've only got parametric equations in terms of x and y, so it must only be in terms of x and y. So basically, we take these two equations and we try and put them back is just the original function in terms of x's and y's, so no t's. So what I just need to do is just play a little game. I need to look at these two equations, and I just need to try and get rid of the t's, effectively. Okay, well, let's have a look. Well, look, I've got x is 2 sine t. I've got x is 2 sine t. And if you have a look at my function involving y, I've got 2 sine t there, so I can just simply replace that with x. So I'm one step closer to getting rid of the t's, okay? I've replaced part of it without any t's, so I've just got y is equal to cos 2t, plus x there. Okay, fine. Now the thing is, I'm just looking at that cos 2t, and the trouble is, I can't really replace x there, because x is only in terms of sine. But do you know what? I know that this is a double angle formula because it's cos of 2 times something, so it's a cos of a double angle, right? And I know my double angle formulas because I've written them out so many times. So if you don't know your double angle formulas, make sure you write them out because this is so important. You can see how important they are, okay? And I know that one of my double angle formulas for cos, there's 3 of them in total. There's cos squared minus sine squared. That's kind of the basic one. But then I can kind of work out other ones just involving sine or just involving cos. I want the one just involving sine, so I know that cos 2t is equal to 1 minus 2 sine squared t. Ooh, that's looking promising. Sine squared t. Well, just remember, I write sine squared t, but what I actually mean there is sine of t all squared, literally the same. The reason why we don't write it sine of t all squared is because it might become unclear if you lose the brackets what's actually being squared. So it's the sine of t all being squared, okay? Well, look, I can totally just rearrange x equals 2 sine t to just get sine t on its own. So sine t is just equal to x divided by 2. I just divide both sides by 2, right? And then all I need to do is just pick that up, okay, and just replace it straight in there. So I just replace that with x over 2. Just replace that with x over 2. Hey, happy days, because look, now if I put that back into my original thing involving y, so if I just pick that up, and if I just put it back into my original thing involving y, so I've got 1 minus 2 x over 2 all squared, okay, then that thing there is just involving x's and y's. Now I guess just because I want to show off, I'm going to put it back kind of in sort of more familiar terms. I'm going to like expand that out and stuff just to show off really. But you don't have to. I mean, this is technically the Cartesian equation of the curve. They haven't told us to leave it in any particular form, so you could totally stop there if you wanted to. But I'm just going to show off. So I've got 1 minus, so I've got 2 times, well look, I've got x over 2 all squared. That simply means that I square the numerator and I square the denominator. So that the 2 squared becomes 4, okay? And then I've still got plus x, but look here. I've got 2 times my fraction. I've got a divide by 4 on the denominator we've got 4, so that means divide by 4. So effectively they just cancel to leave me with 2. So I've got 1 minus x squared over 2 plus x. So that's what y is equal to. That's a quadratic because the highest power is a 2. So I've got y equals, I'm going to write the x squared term first, minus x squared over 2 plus x plus 1, I guess. And of course you could multiply through by 2 and stuff, but that there is totally fine. That looks a little bit like a quadratic.